Hi everybody, I'm Greg Alvarado and I'm here to share a few thoughts with you on fixed equipment reliability. And today we're going to start with some of the basic foundational premises around risk-based inspection. And one of the first things I like to point out is RBI is very much about how much confidence we need to have in what we believe to be the true damage state of the equipment. And in API RP 581 terms, and by the way, API RP 581 is the American Petroleum Institute methodology for RBI. It's very much about managing uncertainty. It's very much about understanding confidence in what I believe the true damage state of that equipment is. And since most equipment is originally designed, for instance, with the ASME Section 8 Division 1 code, with a 3.5 to 1 safety margin. In fact, it used to be a 4 to 1 safety margin. Some people could say that it was over-designed. But then again, we rarely operate equipment the way it was designed to be run. So we've got to have ways to keep an eye on the equipment in its integrity and its reliability to avoid loss of primary containment events. So with a tool like risk-based inspection, one of the first things we have to do is understand what risk really is. Of course, it's consequence of failure coupled with probability of failure. And then we also have to set risk thresholds. What risk don't we want to exceed? And so for most of us that work in the inspection world or the fixed equipment reliability world, corrosion engineers as well, mechanical engineers, what we want to do is make sure that the predictions that we create about things like corrosion rates, cracking susceptibilities, and so forth are as accurate as they need to be. And of course, we don't have unlimited budgets. We don't have unlimited time. We have to be really smart about the way we budget our time and money. So, for instance, we might not be as concerned about a heat exchanger shell with cooling tower water on it leaking as we would be a hydrocracker reactor, a continuous cat reformer, or let's say a double wall low density polyethylene reactor failing. So we're going to want to put more attention on those items that carry a bigger consequence or criticality with them. So that's where this comes into play than the risk threshold. So if there's uncertainty about our remaining life prediction and the corresponding criticality is very high, we want to make sure we lessen that uncertainty in those cases, and we may have to take resources from the lower criticality equipment to apply it to that equipment to do so. And so just to give an example, in the 581 technology, if I were operating a piece of equipment for 20 years and I entered a 4 mil per year corrosion rate as the corrosion rate for that equipment, and it uses that information to calculate a damage factor and then a subsequent probability of failure number, if I've never inspected it, the 581 technology using Bayesian logic is going to debit me for that, and it may actually quadruple the corrosion rate effectively to calculate a damage factor, which may be artificially high. So it's going to tell me you need to go get more information about that piece of equipment. So I go out, I do an inspection, I come back, I take credit for that inspection, I confirm the 4 mil per year corrosion rate or less, and then I see the probability of failure come down because I've increased my confidence in what the true damage state of that equipment is and what the true damage rate of that equipment is. And that's for today, because I did my risk assessment today. Now, if I want to look ahead, say 2 turnarounds or 1 turnaround or sometime in the future for equipment lifecycle management, I also then need to have some confidence about the way that equipment's going to be treated or operated over that time too, and make sure it's kept within those parameters. So this is just one example of how the codes and standards and the best practices that we're creating today, RBI is one of those tools, Fitness for Service, API RP 579, the new joint ASME standard, is another great example. So that's a little bit for today. I want to thank you all for watching, for listening. Feel free to leave comments, questions, and come back again. Enjoyed having you.